Hello and welcome to this new section on operationalizing AI for decision making in this course, AI for data driven management excellence, and the first lecture in this section. In this section, we will give you a good view of how can you use AI for excellence in operationalizing AI for decision making. And in this particular lecture, we will talk about how to use AI to flag anomalies or trigger alerts based on thresholds or patterns. Right. So how do you think you can use AI to flag anomalies or trigger alerts based on thresholds or patterns? Any thoughts on that? Using AI to flag anomalies or trigger alerts is a powerful method for proactive monitoring, fraud detection, and system health as well as customer behavior analysis. Right. Now, what you here you can move beyond simple rule-based alerts, right? Simple rule-based alerts to intelligent adaptive systems that recognize subtle patterns and deviations in real time. Now, how to use AI for such anomaly detection and alerting? Let's take a look at that. So you need to begin by defining the business objective. Now, what could be your business objectives? If your use case is of a website traffic, your objective could be to detect sudden drops or spikes. If your use case is a payment system, you may be interested in flagging suspicious transactions. In IoT and operations, you may be interested in detecting machine failure signs. In finance, you may be looking to trigger alerts on revenue dips or fraud risks. And in customer churn use case, you may be interested in spotting behavior change before dropouts. And that's how you define your business objectives. Then you collect and prepare data. You collect their time series data, which is hourly, daily sales, CPU usage, visits, etc. You would collect transactional logs in terms of purchase amounts, login attempts, and you look at structured features like user activity, geolocation, device type, and then you clean, timestamp, and normalize values and fill missing data appropriately. So that's how you can collect and prepare the data. Then you need to choose the right anomaly detection method, and there are four of them we will talk about here. There could be a static threshold that you could use through a rule-based detection method, which is good for simple and predictable patterns. Say, for example, your rule could be if the temperature exceeds 100 degrees, you send out an alert saying system is overheated or overheating detected. There's the tools are like you can use is Excel, Power BI, Google Sheet, rules and notifications in Google Sheets. Then you could use the anomaly detection methods, statistical anomaly detection, which works well for numeric time series data. And there are different methods for different uses. You could use red score or standard deviation method to flag points 3 sigma away from mean. You could use rolling mean with confidence bands to detect deviations from trends, or you could use interquartile range, IQR, for outliers in batch or stream data. So these are some methods for different usage. Now the tools that you can use are Excel, Python, and in Python, Pandas and NumPy or R itself. The third one is machine learning based anomaly detection, in which you use when patterns are complex and the thresholds are dynamic. And that's where again you start using AI really. And your methods are like isolation forest, which is best for unsupervised multivariate data. And there the tools are scikit-learn and PyCaret. You could use one class SVM as a method for unusual behaviors in fraud and credits. And you could use scikit-learn there again. You could use autoencoders, the neural nets, and they're best for sequence or IoT or transaction data. And the tools are TensorFlows and Keras. And you could use profit plus residuals to forecast and anomaly spotting. And there your tools are MetaProfit in Python or R. So there you what you would do is you simply first import isolation forest from sklearn.ensemble. Then you model isolation forest with fit X data, and then you detect anomalies. So as simple as that it sounds, but it requires a lot of practice to come to that level. Then the last one that we'll talk about is a detection method is the AI enhanced tools with built-in anomaly detection. And there are many of them that you see here. You could use Power BI plus Copilot or Azure Monitor, which can do AI visualization, anomaly detection, and alerts. Then you could use Tableau Pulse, which can monitor KPIs and explain changes. Or you could use AWS Lookout for metrics, which has ML, machine learning anomaly detection as a service. Or you could use Datadog, New Relic, or Splunk, which is for systems, infra, and app monitoring. And then there is last one we talk here is Anodot, Sentry and Dynatrace, which is an AI-based real-time business anomaly alert. So there are a variety of tools available based on the complexity of the work that you have or simplicity of the work. You can choose the right anomaly detection method. Then you trigger alerts automatically. You set up the system to trigger alerts automatically. And there, when the anomaly is detected, there should be a trigger, which is the form of either emails, SMS, Slack, or team alerts, or a workflow. Workflow like stop payment, reroute orders, create Jira tickets, etc. And how can you do that? You can use Power BI to create alerts from dashboard KPIs and set condition. You could use AWS where you use CloudWatch alarms and SNS. You could use Python. In Python, you could use SMT PLIB or Twilio to send notification, or you could use Zapier and Power Automate to connect tools without codes. So that's how you can trigger alerts automatically. Then you need to visualize the anomalies for actions. There you could use AI enhanced dashboard where you can use line charts with anomaly bands using Power BI and Tableau, or smart narrative that explain the deviation using copilots in GPT, or heat maps or scatter plots to show behavioral anomalies. So that's what you do in visualizing anomalies for action. Let's take a look at real-world example of using AI to flag anomalies or trigger alerts based on the threshold or patterns. Now, this is the use case of a revenue drop detection, right? And here, the first step is in terms of data is to uh, monitor hourly revenue from 10 stores, get that data, then model that data by forecasting next 24th with profit, flag residuals greater than 30%. Then you set up the alert, send SMS if more than two stores deviate simultaneously, and the tools that you can use are like Profit plus Python plus Twilio plus Power BI dashboard. So that's a revenue drop detection real life use case example. So look, let's take a look at the tool recommendation by the skill level. If you do not have any coding skill, your right tools for you are Power BI plus Copilot and Tableau Pulse. And what it does, it builds dashboards plus alerts with AI. If the coding skills are there but they're very low level, then you could use Azure Monitor or Lookout for metrics, where you can plug them into data sources and auto learn patterns. Or if you are a professional in coding, you could use Python, scikit-learn, and Profit, where you can do customized anomaly detection pipelines build up. And if you are a real-time ops, then you could use Datadog, Splunk, Sentry, where you can do infra plus application anomaly monitoring dynamically, right, in real time. So these are some ways of the tools stack that you can use by your skill level. Let's summarize the decision flow. Decision flow to use AI to flag anomalies or trigger alerts based on thresholds and patterns. You start by defining what to monitor, obviously, right? Then you choose the detection type. Is it rule-based? Is it machine learning? Then you train and configure the model. And then trigger all alerts automatically. And then visualize and investigate. So simple 5 steps, but a lot of work to be done. So what do we do next? So we will now look at another part of operationalizing AI for decision making, where we will look at how to set up AI models to recommend next best actions for sales, marketing, supply chain, etc. And that's a part of using intelligent decision engines, right? So that's what we will do in the next lecture. So thank you so much for operationalizing AI for decision making, watching this lecture in this course, AI for data driven and management excellence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and do download the PDF file to take a look at anything that you need.